Hey guys, I want to go ahead and continue doing some of these graph analysis FRQs. Today we're going to be working on 2013 and 2014. Just to give you an idea, when you see these graphs, what are they going to be asking you? What to look for? Okay, a lot of times, of course, they're going to give you a graph and you're going to have to analyze it. A lot of times, guys, the graph is going to be the derivative, okay? All right, so let's take a look at this one. 2013, the figure above shows, or here shows f prime, the derivative of a twice differentiable function on the closed interval between 0 and 8. The graph of f prime has a horizontal tangent line. Okay, that's important. So that means at x equals 1. So let me do that here. Okay, x equals 3 and x equals 5. Horizontal tangents. Okay, the areas of the regions between the graph of f prime and the x-axis are labeled. The function of f is defined for all real numbers and satisfies f of 8 equals 4. That's our initial condition. All right, so now remember, part A is the easiest part of all. It says find all values of x on the open interval between 0 and 8 for which the function f has a local minimum. Okay. All right, so this one, remember, they're asking for a minimum. And what do they give me? They give me a graph. Okay, they give me a graph. Okay. Now remember, and I think your teachers went over this, but see, all this is the derivative. So you see all these are all slopes that are connected and they make a smooth line. So right here, all the slopes here, okay, from 0 all the way up to here, what is that? 2, 3, 4, from 0 to 4, okay, all of these the slopes are positive. How do I know that? Well, because they're above the x-axis. All these are slopes that are connected, okay? So all of this is going up. The function, the original function, f of x is going up. And then here, all these are slopes that are connected, and these are going down. Okay, so here the slopes are positive, and then it goes to negative, okay? And then it goes from negative, and then it goes to positive, okay? And if you wanted to draw it like a number line, okay, you would say positive going up, going down, and then again, what is that, positive? Kind of like that. That's kind of like your number line per se. So what I notice, see, it goes from minimum, from minus to plus, minus to mas, I tell my students. So this is a minimum right here. Right here, this is a critical point right here. Okay. And because this is the graph, I already know that this is a minimum because the slopes goes from negative to positive. Okay. So you would say at x equals 6, okay, you would say the critical point, and I'll just say it for just for sake of time, guys. So at x equals 6, the critical point has a local minimum, okay? Why? Because f prime changes sign from negative to positive. And that's it. That's your justification. So you got to tell them that it goes from negative to positive. That's the key verbiage right there. So at x equals 6, the function f, you can just use this. The function f has a local minimum. Why? Because f prime goes from negative to positive, and that's it. That's all they want to see. Okay? And that'll give you that 1 point. Okay, and you'll notice that a lot of these, they'll ask you for the minimum, the maximum. So you have to be able to analyze it. But if you understand that all these are slopes that are connected, these are positive slopes that are connected, these are negative slopes that are connected with a smooth line, and you understand this number line, it makes sense. Letter B, determine the absolute minimum value. You see that difference? There's a difference here. Right here, they're asking for a local minimum, but it just says minimum, doesn't it? Right here, it says absolute minimum what? Value. So I have a minimum at x equals 6, but what is that value? So I hope you notice that little difference. So determine the absolute value of f on the closed interval between 0 and 8. Justify your answer. Okay, so remember, it's like almost those rate accumulation problems. I know I have a minimum here, okay, but what is the value, right? I have to plug it into something. Like what's the value going to be? Well, remember when we did the rate accumulation problem, you have to check the beginning, okay? You have to check the middle. You have to check the end. Okay, well, what's the beginning? 0. I got to figure that out. I got to figure out the middle. Well, our critical point is 6, okay? And I got to figure out the end. That's what I got to figure out. Well, how do I do that if they give me a graph? Okay, how do I get f from f prime? Well, you're going to do the antiderivative of what? F prime of x dx. Okay, from where to where though? Well, what's your initial condition? 8, huh? We start off at 8. And what do they want us to find out? Well, I got to find 0 first. Okay, do that. Then what do I have to do? Well, I have to find the one at 6. Okay, so you got to do the antiderivative of f prime of x. And you goes from what? The initial condition starts at 8. It goes to what? To 6. And then lastly, same thing. Or f of 8, we already know is 4. Okay? So if I do my fundamental theorem, okay, of calculus, instead of f prime of x, I end up with f of what? F of 0 minus f of 8. Okay? Now I got to rearrange it so I can get f of 0. So, okay? So this becomes, put an arrow there, it becomes f of 0, leave it right there, bring the negative f of 8 to the other side, becomes a positive f of 8. Okay? And then plus the integral from 8 to 0 of f prime of x dx. Okay? Now, this is just me. I don't like the integral going from high to low. You see that? It goes from 8 to 0. What I'm going to do is I'm going to reverse it. I'm going to change it. Okay? And when you reverse the limits of integration, remember it changes into a negative, so it goes from 0 to 8 of f prime of x dx. Okay? So now let's go ahead and find f of 0. Okay? F of 0. What's f of 8? Your initial condition. It's 4. Okay, nice. Minus. What's the integral from 0 to 8? Well, they gave me a graph, don't they? Well, that means I have to find the area underneath the curve from 0 to 8. Well, here's 0. I have to go all the way to 8. What's the area? 2, 6. Okay, that's 8. 3, right? But that's below the x-axis. So 2 plus 6 is 8. Take away 3 is 5. 5 plus 7 is 12. So 4 minus 12. So f of 0 is going to equal to negative 8. Okay? Now I got to figure out this one. Same thing. If I do my antiderivative, I get f of 6 minus f of 8. Okay, now I got to solve for f of 6. Okay, so f of 6 equals, bring the negative f of 8 to the other side, becomes a positive. Okay, plus the integral from 8 to 6 of f prime of x dx. Okay, I don't like to see these limits like this, so I'm going to switch them. F of 8 minus, I'm going to go from low to high, 6 to 8 of f of prime of x dx. So that'll give me f of 6. Okay, so f of 6, f of 8 we know is 4 minus, now we need to go from 6 to 8. Where's 6? Here's 6 to 8. So from 6 to 8, the area is 7. So the f of 6, the value of f of 6 is negative 3. All right, so in the beginning, we get negative 8. So let me erase that. Negative 8. F of 6, we get negative 3. And f of 8, we have 4. So the absolute minimum value is at, there you go, in the beginning, negative 8. Okay? But notice how we did that, right? So minimum value, okay, I know that's at 6. Okay. But remember, they want the value. So then I got to check the beginning and the end. So beginning, middle, the end. Well, how do I figure out f of 0? Well, they give me f prime. Well, how do I get f prime? You take the antiderivative. Notice what we had to do. The fundamental theorem of calculus. Okay. And then rearrange it to find the value of f of 0. All right, guys? So hopefully that makes sense. Part C, okay? On what open intervals between 0 and 8 is the graph both concave down and increasing? Now remember, concavity, we're talking about the second derivative. Increasing, decreasing, we're talking about the first derivative. Okay, and let me see here. I guess I can do it down over here to the left. So remember, all of these are all, this is f prime. So these are all my slopes. So I know that f prime, see, all of these are positive, connected, connected, connected. So I know it's increasing from here, from 0 all the way to 4. See, the slopes are positive, so it's increasing here. And it's also increasing from 6 all the way to 8. Why? Because the slopes here are positive. All these are slopes that are just connected with a smooth line. Okay, so these are all positive, positive, negative. So it's increasing here, decreasing here, increasing here. Now, how do I find the concavity? Well, remember, concavity is the second derivative. So what do? You actually look at the graph and you look at the slope. So look at from here to here, you see how it's going down? So that's a negative slope. So the second derivative that is going down is concave down. Okay, this little part right here. Okay, concave down. And then what about from here to here? This next section right here. That one is going to be concave up because the slope is positive. Now from here all the way down up to here, that guy is concave what? Is concave down. See, it's going down. And then from here all the way up here is going to be concave up. Now the question is, where is it both increasing? Okay, so I'm looking at this part and this part. Increasing and then concave down. So it's going to be here and then here. You see that? Concave down here, concave down here. Okay. Over here, no, I can't use that. I mean, it's increasing, but it's concave up. So concave down, concave down. So then it would be from 0 to 1 and from 3 to, what is that, 4? Yeah, so you would write from 0 to 1 and 3 to 4. Okay. And how would you say that? Well, believe it or not, all you got to do is say the function, okay, or the graph of f is both concave down and increasing between these two intervals. And actually that's it. That's all you can do. Okay. Because, and then they understand. And if you want to label it, that even helps more because that shows the grader, okay, well, they know what they're talking about. Okay. Remember, they want to give you the points. These are human beings. They're not out to get you. Okay. They want to see the justification. Now remember, a lot of us are more visual than anything else. So draw pictures, your label, all right, and it'll help you out. Last part, part D. The function g is defined by g of x of f of x to the third. F of 3 is equal to negative 5 halves. Find the slope of the line tangent to the graph of g at x equals 3. Okay, find the slope. Line tangent, all I'm already thinking, derivative, okay? But they only want the what? They only want the slope. They only want the slope at x equals 3, okay? The line tangent, but they only want the slope. So hopefully you guys can see that. So we have right here, this guy right here, g of x. So I got to find g prime of x. So what does that become? Power rule, remember, 3 times f of x to the second power times the derivative of the inside. So that becomes f prime of x. Now all I got to do is plug in the 3. And we get 3 times f of 3 to the second power times f prime of 3. Okay, what's f of 3? They tell me f of 3 is negative 5 halves. So that's very helpful. 3 times negative 5 halves squared times. Now f prime of 3, this is where we got to be careful here. F prime of 3, we go to our graph. This is f prime. So f prime of 3, 1, 2. So when x equals 3, okay, what's that value? It is 4. Okay. It is 4. Now be careful. Don't think that you got to find the slope. No, no, no. That would be the second derivative. At x equals 3, what is the value on the derivative function? So the value is 4. Okay, f prime of 3 is 4. And then we go ahead and just solve it. Okay, we end up with 3 times 25 fourths times 4. The 4's cancel out, and the value is 75. So g prime of 3 is 75. Okay, guys? So I want you to pay attention to just how much, what the type of questions they're asking. So let's go ahead and do one more, 2014. This is from 2014, okay? Again, they gave us a graph. The function f is defined on the closed interval between -5 and 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g of x be the function of the integral from -3 to x. Find g of 3. Okay. Well, so remember, part A is the easiest one. So g of 3. Okay, g of 3 is there. You want to plug it in here. So if it goes from -3 to +3 of f of t dt. Okay, and usually this guy is the derivative of this guy. And we'll find out that it is. Okay, well then, how do you do that now? Okay, well remember, okay, from -3 to 3, they gave me a graph. It's the area underneath the curve. Okay, so from -3 to 3, so from -3 all the way to +3, 1, 2, 3 is right here. And now remember, okay, above the x-axis, the area is positive. So I have a triangle and I have another little triangle. So we get 1, 2, 3, 4, 5. 1, 2, 3, 4. So 5 times 4 is 20. Okay. And half of 20 is 10. Okay. Now what about here? That's 1 times 2. 1 times 2 is 2. But half of 2 is 1. So -1. Well, why minus? Because remember, it's below the x-axis. So this area is below the x-axis, so that's negative. This area is above the x-axis, so it's positive. So the answer is 9. Okay, and that's it. That's it, guys. So you just plug it in. All right. Part B. On what open interval between -5 and 4, -5 and 4, is the graph both increasing and concave down? You see that again? Same type of question they asked in 2013. Okay, so remember, this is the derivative. Okay, so that means these guys over here, these are all positive slopes that are connected by a smooth line. So over here, all of this from -5 all the way to 2 over here, okay, the graph is increasing. From 2 to 4, the graph is decreasing because the slopes are below the x-axis. Okay, so where is it concave down? Okay, so we're only looking at from here to here because that's where it's increasing. Okay, that's the first derivative, and now we're looking at the second derivative. So I got to look at the slopes of these guys. Where is it concave down? You see from here to here. See how it's going down? So that guy right there is concave down. From here to here, you see how it's going up? That guy is concave up, and then from here to here again, it's concave down. So where is it increasing? And then concave down, so it looks like it's going to be from -5 to 3. So -5 to 3. And from 0 to 2. 0 to 2. Okay. And if you want, you can just say g prime of x is equal to f of x. Or the graph of f is the derivative of g prime. And it makes sense because if you take the derivative of this guy, you would end up with just f of x. Remember, the derivative of the integral cancels that out, and you just plug in the x. All right, guys? So hopefully that makes sense. So from -5 to 3 and from 0 to 2, you would say the graph of g is both increasing and concave down. Okay? And that's it. Okay, and then you can label it, and that should suffice. All right, guys. Part C. The function h is defined by h of x is equal to g of x over 5x. Find h prime of 3. So I have to take the derivative of h, And you notice, what do they throw in? They throw in the quotient rule. So low d high minus high d low all over the square of what's below. So low d high, the derivative of the high is g prime of x minus high times the derivative of the low. The derivative of 5x is 5 all over the square of what's below. So you square that guy. Cool. Now what do? All I got to do is just plug in my 3. All right. So that means 5. I'll just put it in here times g prime of 3 minus g of 3 times 5 all over 5 times 3. I'll just put 15 squared. All right. So 5 times 3 is, I know is easy. That's 15. Okay. Now what's g prime of 3? Wow, man. Well, how do I find that out? Okay. G prime of 3. All right. We're going to go ahead. If you don't know, like, man, how do I figure out? Well, I know that's g, but that's g of x. Well, take the derivative of it. So remember, if you take the derivative of this guy, g prime of x, that means you take the derivative of the antiderivative. That cancels out. So you're left with f of x. Okay, so you see how I did that? So now I can plug in the 3. So g prime of 3 is equal to f of 3. Okay? So g prime of 3 is equal to f of 3. So what's f of 3? This is my graph of f. Okay. So when x equals 3, 1, 2, 3, what's the value? The value looks like it's negative 2. Okay, you see that? When x equals 3, the value is, y value is negative 2. So g prime of 3 is negative 2. Minus, now what's g of 3? Hey, we already found it. Remember part A? G of 3 is what? 9. Very good. 9 times 5 over 225. All right, that means 15 times negative 2 is negative 30 minus 45 all over 225. That's negative 75 over 225. Now, guys, believe it or not, leave it like that. Leave it like this on the test. You don't have to reduce it. I'll reduce it just because, I mean, I have no pressure on me. But when you have time and you got this and you got to upload, and you know what, just leave it like that. That's perfectly acceptable. They'll give you the full points, so don't worry about it. Okay? Because if you mess up, the whole thing is done for. Because it's not the right answer. They'll take away a point for that. Okay? All right. So part D, last one. The function p is defined by p of x. Find the slope of the line tangent at x equals negative 1. Same type of question they asked last time, in 2013. Okay, so how do I find the slope? Well, you got to take the derivative of this guy. Okay, so I know p of x, so how do I find p prime of x? So, well, how do we do that? Well, I just take f, do the derivative, leave the stuff inside, times, but since now you have the chain rule, you got to take the derivative of x squared minus x, so you're going to get 2x minus 1. Now, all you got to do is plug in that negative 1. So p prime of negative 1, f prime. Now be careful here, okay? Be careful because there's a bunch of negatives here. Okay, you see that? That double negative? Sometimes it's tricky. So 2 times negative 1 minus 1. Don't try to do it on your head. First plug them in and then do it in your head because you're able to see it. If you just try to do it in your head all at once, you will make a mistake. So be careful. So f prime. So this becomes 1. 1, this becomes plus. So 1 plus 1 is 2. So f prime of 2. 2 times negative 1 is negative 2 minus 1 is negative. So now we got to look at f prime of 2 and figure that out. So we go over here to my graph of f. Okay, so we got to go to f prime of 2. So remember, this is the graph of f. Okay, what is f prime of 2? Remember, this is the graph of f. Okay, so how do I figure out f prime of 2? Okay, we got to get f prime of 2. So now at x equals 2, okay, now at x equals 2, the value is 0. But they're not asking for the y value. They're asking for f prime. So I actually have to find the slope of this line at x equals 2. So I have to find the slope of this line. Well, that's pretty easy because you go 1, 2, 3, down 4, and 2 to the right. So negative 4 over 2. So the slope is actually negative 2. Okay, pretty tricky, huh? So this would be -2 times -3. So it would equal to +6. And there it is, guys. So hopefully now you're able to start seeing, what they're asking for, what they're looking for, how they design the questions. And I think the more you see in tomorrow's lesson with 2015, 2016, that the questions are coming up the same type, the same scope of questions. All right, guys, I'll see you guys next time.